Evolution, not a chance. You know, I spent my whole career in science, pretty high level of science. And I was never challenged by evolution, not so much as once. I mean, it was ludicrous. It was completely non-scientific. One can hardly really follow it through to its logical end without becoming an atheist in the process. Why is it I didn't have any trouble with it when we have all of these theologians out there who appear to have problems with evolution and old Earth and whatever? Do they know something I don't know? I mean, if they do, I'd kind of like to hear from them. Well, several years ago, I was giving a lecture. I've been talking about these things for years. And I happened to use an expression I think you've probably heard. It takes more faith to believe in evolution than it does in creation. Have you heard that? Yeah, well, I said that, and the guy came up afterwards from the audience. I learn a lot from my audience, so feel free to feedback. A fellow came up and says, I don't think you're really using the word faith properly. At least you're not using it in a biblical sense. He says, the Bible defines faith as the substance of things hoped for, the evidence of things not seen. Wow, we usually don't think of substance and evidence when we're talking about faith. But God's word is so reliable that it's substance and evidence. It's that more sure prophecy that we have in Scripture. So I don't use the word faith anymore. He told me, he says, I think the word you're really searching for is credulity. It takes more credulity to believe in evolution than creation. Well, at the time, I wasn't sure what the word meant, but hey, I'm a professor. I can't admit this. So I said, excellent point you have there. And I went home, looked it up in the dictionary. And it means willingness to believe without evidence. Simple as that. And that indeed is what it takes to believe in evolution. Let's dig into that. Evolution is ultimately based on chance. Can't get away from it. Jacques Monod was a very distinguished scientist, now deceased. He was a Nobel Prize winner and an atheist. And he wrote a book called Chance and Necessity. It got this name because he says everything you see in all of the natural world is a result of chance and or necessity. What did he mean by necessity? The laws of nature. So chance plus the laws of nature explains livers, kidneys, spleens, thymus, oxyntic cells of the parathyroid, Albert Einstein. The whole works. He said, and I quote, chance alone is at the very source of every innovation of all creation. He's using the word creation in a different sense than we are. All creation in the biosphere. Pure chance, absolutely free but blind, is at the very root of the stupendous edifice of evolution. I'll give you one more quote just to hammer this home. Julian Huxley, very famous evolutionist, said this with regard to evolution: nowhere in all of its vast extent is there any trace of purpose or even of prospective significance. Evolution is impelled from behind by blind physical forces. I love this next expression. Evolution is a gigantic and chaotic jazz dance of the particles and radiations. That would have been a good place to put a period right there. But he didn't. I think sometimes God just comes down and takes people's minds and just does this with them. He should have put a period there. You know what he wrote after that? You're not going to believe this. Remember, chaotic jazz dance of the particles? In which the only overall tendency we've so far been able to detect is that summarized by the second law of thermodynamics, the tendency to run down. Wrong way. Evolution needs to go up someplace. You just can't keep going down and down and down and down. You know, we need to go up. I can't believe he wrote that. It's just incredible. Well, several years ago, just to emphasize the role of chance in evolution, a colleague of mine and I visited the Field Museum of Natural History in Chicago, one of America's great natural history museums. And they were once again doing their sort of twice annual evolutionary indoctrination at taxpayers' expense. And in order to get across the idea of chance in evolution, they actually incorporated a little gambling casino into the presentation, or into the whole exhibit. Here's a picture of it. I saw these two kids go through, I guess, their brother and sister. I kind of like to think of them as Tommy and Sally. They stopped off here at the first table. That's known as a dice layout. They have these in gambling casinos, I've been told. And they had a lot of fun here, Tommy and Sally. They were just throwing the dice away and just throwing the dice around the place. And I'm glad, actually, that a lot of young people don't read anymore. Because if they did, over the top was a sign that says, "Is life just a game of craps?" You know, craps is a slang expression for dice game of chance. Tommy, your sister Sally there, is she just like one big crap game? Your mother, your father, your Christianity, is it all just a game of craps? All just a matter of chance? Man, I wonder if these kids were prepared to deal with this. The parents probably dropped them off at the museum, hoping they would be entertained and, if by some perhaps outside chance, possibly educated. And they get hit by this. Is all of existence just one big game of chance? I wonder if their church prepared, their Sunday school, or did they have to deal with this cold? It's a pretty young age to get hit with this, huh? Oh, it's getting younger and younger. They're doing it in first grade now. Then they moved over to the one-armed bandit. And the one-armed bandit had a sign over the top of it that said, "Over time, tiny mutations add up to big changes." Well, they got one thing right. Tiny mutations can indeed add up to big changes. I can show you a picture of a tiny mutation. These are called HeLa cells, named after the donor who died of cervical cancer many years ago. HeLa cells have become something of the guinea pig of the cell biology world. These cells just kept dividing. Unlike most cells in our body, get about 15, 20 divisions, and that's the end. There's a little thing on the end of the chromosomes called a telomere, sort of like a string of tickets. So you get 20 tickets for the fare, for the rides, and when you spend the 20th ticket, the party's over. That's one of the theories for the abbreviated life we have. We were created to live forever. And that may be one of the explanations why we don't. In any event, these cancer cells have just kept dividing. Since Henrietta Lacks died, which was about 60, 65 years ago, it's been estimated that approximately 20 tons of cells have been harvested from her body. Dr. Johannes Salk used these cells to help crack the problem of polio. So they've been very beneficial. But these are some really sick cells. They have a lot of mutations in them. You'll notice some of the nuclei are bigger than others. There's odd numbers of chromosomes. They don't divide cleanly. You'll never get a cervix out of these cells, even though the genetic information was there at one time. You're sure never going to get a Henrietta Lacks out of these cells, although at one time the genetic information was presumably there for that. That's a tiny mutation for you. I got a tiny mutation working on me right now called cancer. Doesn't seem to have improved things any. It's made life a little bit more difficult. So that's the nature of tiny mutations. If an evolutionist attends my lectures, as they often do here in the museum, they often raise their hand and say, "Yeah, but you're overlooking natural selection." You've all heard of natural selection, right? We creationists need to be careful when we say we believe in natural selection, because what we believe in is a very minor subset of what the evolutionist has in mind. To the evolutionist, natural selection does everything for evolution that God does for creation. Boy, that better be some theory, huh? It better be good. If it's a God replacement for creation, it better be good. Let's look at it. First of all, what are we selecting? We're selecting mutations, and there are other sources of genetic variation, but the mutations we're talking about are random. Now, we do have purposeful mutations in our body that are actually programmed in that serve beneficial functions. For example, when cells are exposed to heat, they can make heat shock proteins due to a mutation. But these are programmed mutations. They're predictable, they're repeatable, and they're reversible. This is not true of evolution. It's not predictable, it's not repeatable, and it's not reversible. So we're talking about the random mutations. Now, I hope this doesn't come as a huge shock to you, but you cannot select what mutations do not provide. Can't select something that isn't there. A dog can't say, and I know my dog has thought this from time to time, "I wish I had wings." I could get up in this tree and I'd really nail a squirrel. Now, if you want to do an experiment, I have an experiment for you. Go down to Midas Muffler Shop and order a dozen yellow roses. You're not going to get them. You know why? They don't stock them. That's pretty obvious, isn't it? They don't stock them. Natural selection can't select things that aren't stocked, things that aren't there. So you already have to have a random, purposeless, goalless, mindless mutation to select from. And you can't say, boy, I could really use this mutation. No, it doesn't work that way. Another feature about natural selection is it's been given the explanation is survival of the fittest. You ever thought that one through? Which creatures survive? Those which we describe as being fit. Isn't that true? The fit survive? So which creatures survive? It would be the fit. What exactly do you mean by fit? Well, it's those creatures which are able to survive. So which survive the fit? What do you mean by fit? They're able to survive. Which survive the fit? What do you mean by fit? They're able to We call this a tautology. If you're interested in tautologies, I'll give you another one. Do you realize in America today, deafness is the principal cause of total loss of hearing? It's true, but it's trivial. It has no explanatory power at all. Evolutionists were aware of this over 50 years ago, and population geneticists came up with a completely different definition that has slightly more explanatory power. They said, look, in evolution, the individual counts for nothing, totally insignificant, whether human or rat or lice or whatever, the individual counts for nothing. It's the population, it's the only thing that really counts. And so the population geneticists said, it's not simply a matter of survival of the fittest, it's differential reproduction. In other words, those that leave the most offspring, they're the ones that get to play the evolution game. So whenever you have a mutation, you ask yourself, is this going to result in more offspring, less, or no change? Evolution happens only when it results in more offspring. So I figure another 500, maybe 1,000 years, this will filter down to our grade schools and high schools, and we'll have a proper definition of natural selection. But think of it, random, purposeless, mindless, goalless change, plus does this lead to more offspring or not? That's it. That explains how an expanding cloud of hydrogen gas at the time of the Big Bang, which I don't believe in either, has two problems. Initially, it wasn't big and it didn't bang. Other than that, it's all right. But from the time of the Big Bang, you get an expanding cloud of hydrogen gas, which over time, is supposed to evolve into people. One wag has said, hydrogen is a colorless and odorless gas, which if given enough time, turns into people. I don't believe that, and they think I'm weird. Now, if you're talking about genetics, you just can't point to anyone more prestigious, more deservedly famous than Dr. James Crow. He was formerly professor and chairman of genetics at the University of Wisconsin. He probably has trained more distinguished genetic scientists than any other individual in America. And this is what he said about mutations, and he's an expert on it. The typical mutation is very mild, thank God. It usually has no effect, but shows up as a small what? Decrease in viability or fertility. Wrong way. We were thinking of going up, weren't we? More offspring, play the evolution game, not down. By the way, now that he's retired, he's spending his years on a special evolutionary study group that represents sort of the cutting edge of where evolution's going in the future. Have you heard of mutation repair? You really ought to hear about it because none of you'd be here if it wasn't for mutation repair. It turns out that in a given day, we can have up to 1 million molecular lesions in our DNA per day. And these get corrected, not all of them, but most get corrected by a mutation repair process that comes in. What it does, DNA is a double-stranded affair. You may have heard of that. Mutations usually occur in one strand or the other. The bad strand is snipped out by special enzymes and thrown away. A complementary copy, is made of the good strand and it's spliced in where the bad strand was. And without that, you wouldn't be here. It's been estimated without DNA repair mechanisms, there's not a single living creature on Earth that would have survived. Every creature ever studied has these mechanisms, from bacteria to humans. It involves several different enzymes to make it work. Unfortunately, it doesn't get rid of all mutations, but it gets rid of enough that if we didn't have it, you wouldn't be here. And you want to think of something interesting? How about a mutation of your mutation repair system? Wouldn't that get spooky? I mean, there's a lot of enzymes involved. You could have a mutation of one of the amino acids in one of the enzymes. Sadly, it happens. It's a disease called xeroderma pigmentosa. To show you a picture, I don't think you want it. It's fatal before reproductive age. Even the light hitting your skin right now is causing mutations, which are being repaired even as we speak. And without it, cancer runs wild, melanoma, and you die, whether you're a bacterium or a human or a mouse or a rat or a cat or a dog or a giraffe or name it. Well, what about this credulity thing? Credulity is willingness to believe without evidence. If I had a coin up here and I flipped it and I said heads, would you go along with that? Even though you didn't see it? Flip it again, another head. Could you live with that? 2 in a row? Heads, third one. At the 100th head, what do you know for sure? I'm doing something. You may not know what I'm doing. It may be a 2-headed coin. I may be just lying about the heads, or I do a little sleight of hand to make it come up a head. But whatever I'm doing something. You simply cannot accept that you'd get 100 heads in a row. Would you agree? I mean, somewhere along the line between, say, 3 or 4 and 100, you'd put your foot down and say, I'm not going there. Well, we call that credulity, and I thought it would be kind of fun to actually measure your credulity factor. What are you willing to believe is a result of chance? Now, mind you, anything I show you is so likely compared to evolution, you could call it a certainty. But what is your credulity factor? How improbable of an event are you willing to believe is a result of chance? Let's test you on that. 4 colors. Happen to have some little cards here. They have these 4 colors on them. There's the green, there's the blue one, a red one, a yellow one. Now, I could write down one of the colors. You could think of one of the colors. What's the chance that the color you're thinking of would be the one I wrote down? 1 chance out of 4. It's not a big deal, but 1 chance out of 4. So I thought, well, let's play that little game. Somebody told me that, well, people have favorite colors. If you ask a woman, they're more likely to pick blue than the others. So perhaps the way to get around that is we shuffle up these 4 colors here. So I don't even know where they're going. Just get them mixed up here. And put them down here. And I made up this little board here, 1 through 4. And so without even looking at the colors, we'll just place 1 in position 1 here. So that would be choice number 1. Choice number 3 down here. Choice number 2 up here. And choice number 4. So instead of picking a color, you'll pick a number. Now, I have made a prediction. The prediction's on the backside over here. It's this card. It has a color on it. Could be the very color that you select. Just 1 card here. I'll leave it peek up over the edge so you know it's there. So anybody, just pick a number, 1 through 4. 2, okay. You sure you don't want 3? I mean, I don't want you coming back later saying, I wish I would have picked 3. Okay, number 2, let's see what it is. Number 2 happens to be the red card. Are you ready for this? We should have a drum roll. Ready? Ta-da! I want to thank you all for that wonderful round of indifference. Okay, it's not much of a trick. It's not like you're going to be sending a letter home. Dear Aunt Millie, I was just at the Creation Museum. I saw this man do the most incredible thing. He picked 1 out of 4. Nobody really cares. But even on a mere 1 out of 4, how many people think I've already done something to make this happen? Oh my goodness, almost all of you. This is probably the most skeptical group I've ever worked for. When I get around to talking about evolution, I don't even want to hear from you, okay? You're done. You can't live with 1 out of 4. You're done when we talk about evolution. I simply can't believe that you think already I've lied and cheated. But that's the kind of magic I do. That's why I don't do gospel magic. You really don't want to use lying and cheating for that. I'm not picking anybody else. It's just the type of magic I do. It involves lying and cheating. Okay. I always tell people, it's okay to lie and cheat as long as you tell them in advance you're about to do so, and then you do so for educational purposes only. So you could have picked number one, right? I don't know why you did, but you could have picked number one. Could have picked, I just hate myself. I can hardly sleep nights when I do this kind of thing. And finally, you could have picked number four, which it's called lying and cheating. In other words, to make even 1 and 4 come out, I just wouldn't have the chutzpah to come out here and do this and leave it up to chance. I have to be in control somehow. So when we see even something as simple as 1 out of 4 right away, we think, I don't think you left that to chance. But let's crank up the probability problems a little closer. Have you heard of ESP cards? There was a guy at Duke University called Dr. Ryan. He came up with this ESP, extrasensory perception, sort of the ability to read somebody else's mind. And he made up these cards which are sufficiently different from one another that you can't really convert one into another. They're fundamentally different symbols. And people used to entertain a lot easier than they do today at parties. You'd get a couple of packs of these. Here's one, here's another pack with the ESP cards. And you get 2 people, and they each, arrange them in a certain way. Then they would lay them down. The other person would lay theirs down. Now, if 2 lined up, you had a little ESP. Or 1 lined up, you had a little ESP. If 2, you had a little more. It was a kind of a self-fulfilling prophecy. So I thought, what are the chances that somebody would get, all of them right? And the math on this is quite simple. It's called 5 factorial. There's 5 different things. You have 1 chance in 5 of coming up with a wave, if that's what the other person had. If you get that, you have 1 in 4 getting the square, if that's what the other person had chosen. And then 1 in 3, 1 in 2, 1 in 1. And so to get the whole chain, it's 5 times 4 times 3 times 2 times 1. And that means you would succeed approximately once in 120 tries. We don't have anything like that amount of time, so what I thought we'd do is take the ESP cards, just shuffle them up here, this one, take this little pack and shuffle it up, and made up this little lucite board. And I thought what we could do is just put these cards in different places on the board, and let's put one on the top up here to kind of balance it out. And let's put another one in, put this one in the middle. That'd make a nice symmetrical pattern for us. And then we need to fill in the other 2 areas yet. Put one down here. And we put one up here. Now, I don't suppose you have any idea what particular sequence I have them in. But I just want you to guess. Number 1 through 5. Where should this one go? 1, okay. Goes in position 1. What about this one? 3, okay. It goes down here in position 3. Oh, no, 3's here, right? A little bit of lying and cheating here. What about this one here? 5, okay. It goes down here in 5. And then this one? 2. And on the last one, I'm actually able to divine where you're going to want to put it. It's a shame to cover such a brain with hair. Not much, but some. Anyway, I think you did really well. I mean, for 1 chance out of 120, man alive, you folks are on. How many think I left that to chance? No one. You're done, right? 1 out of 120, and you are done, for sure. Nobody is going to go there, okay? Don't gamble. Like the man said, it was getting aboard the gambling boat. He says, I sure hope I break even today. I could really use the money. Now, what is the chance of spelling the word evolution? That could be fun, huh? I have some alphabet cards. You probably learned your alphabet from cards like this. They should spell evolution, E-V-O-L-U-T-I-O-N. Evolution. Assume the 2 O's are different, O number 1, O number 2. And if you assume that, what's the chance of just shuffling away on a pack like this and having it end up spelling evolution with the 2 O's in the right order. Well, let's just look at the math on that one. It would be 9 factorial, because there's 9 letters. 1 over 9 times 1 over 8, so forth. Basically, you succeed once in 362,880 tries. This is a certainty compared to evolution. I mean, this should be nothing. You shouldn't even be impressed if we can do this. But I thought, let's have somebody be the evolutionator here, okay? We got an evolutionator here. Maybe one of you would just come up here and grab the pack. Just shuffle, 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 shuffle. You're going to be like evolution, right? I mean, we're talking crazy. Just keep going. And then let's see. Wait a minute. To make a protein, it's more difficult than this. For example, I'm sorry, I'm going to have to use a molecular modeling kit to explain this. It's not enough to get things in the right order. Proteins, on average, have 400 amino acids in them. And we have 100,000 different proteins in our body, each averaging 400 amino acids long. We know from experience you can be off by 1 or 2 amino acids that can destroy the function of the protein. To explain why we need to get more than just the right order, I have to use a molecular modeling kit. I hope this doesn't get too technical, but I brought out my molecular modeling kit. And inside are these snap beads. And these snap beads are like amino acids. I have 9 of them, and they're all different color, different shapes, see? And the amino acids, there's 20 different ones. So a particular protein has 400 amino acids, and each position could be any one of 20. So to figure out the probability of getting a protein, it'd be 20 times 20 times 20, about 400 times. And you get a really big number. But it's not enough to get things in the right order. Look, I'm going to be the evolutionator. And if I dump them out, what order are they in? They need to link together, right, to get an order. And that's what happens in proteins. We have something called the peptide bond. Here's amino acid 1, here's amino acid 2. They get together and an enzyme splits off water and produces a peptide bond. With these little snap beads, we can illustrate that. There's 2 different ends, just like there's an amino terminal, hydroxy terminal up there, OH in one end, NH2 in the other. This has 2 ends. It has a button on one and a socket on the other. And to get them to form a chain, you have to use energy, like that. Now, in a cell, the energy is not enough. You also need enzymes to get these things to hook together. If you just used energy, it's been calculated, it would be 1,000 times more likely that you'd break any existing bond than that you'd make a new one. Boy, that's going in the wrong direction, right? So we have to figure in addition to shuffling the cards, we have to figure out a way to illustrate a peptide bond. I've come up with an idea that's really nuts. I hope you don't just flee on me, but I thought, well, what if we were to take a ribbon? I think this ribbon ought to go to a young lady. How about this young lady back here? Would you just come up and grab this ribbon for me, would you please? Thank you. You might just temporarily sit in the front seat here because I'm going to need your help in a bit. So she has the ribbon. You have the cards. You've been shuffle, shuffle, shuffle. Now the peptide bond. You're going to love this. Paper clips. What we're going to do is we're going to throw the cards in a sack. We're going to throw the ribbon in a sack. We're going to throw the paper clips in a sack and then kind of go boochie, boochie, boochie a few times like this. And we're hoping that the cards will become paper clipped to the ribbon to spell evolution. Hey, it's a long shot, but compared to evolution, it's a certainty. So if somebody want to be in charge of the paper clips, one of you fellows here, just grab the paper clips here and hang on. You may shuffle them if you like. There we go. Thank you. Okay, now for the sack. I want to thank my pastor of my church. I asked if I could borrow our collection bag. He says, you may not only borrow the collection bag, you may keep the collection bag. I said, why? He says, since we got this bag, our contributions have gone down to nothing. And I think I figured out why. This could explain a lot right here. You see, this trick is like all my tricks, you can see right through it. What I did was to mount a zipper in the bottom. Voila, problem solved. So let's see, you had the cards, okay? Would you just come up and throw the cards in the bag and look in there, make sure they're in there. They're in there, okay. You have the paper clips. Just throw the paper clips right on top of the card. You see them down in there with the cards? Okay, and this young lady has a ribbon. Did I tell you that I was going to ask you to come up and stand by me in front of this absolutely frightening audience? Would you do that, please? Come right up the steps. Be careful there. What's your name? Anna? Hannah. Let's have a hand for Hannah for being brave enough. Now, Hannah, what we're going to ask you to do is on the count of 3, you're going to have the ribbon all balled up tight. You're going to throw it in the bag. First, look in the bag. You got the paper clips and cards in there. You're going to throw the ribbon in the bag and then just reach in and pull the ribbon back out again. That's pretty simple, huh? So you ready? On the count of 3, 1, 2, 3, throw it in the bag. Just reach in the bag, grab a hold of the ribbon. Oh my goodness, what do we got going here? Oh my, Hannah, I think we may have done an evolutionary event. Thank you so much, dear, for your help. Don't trip, whatever you do. There you go. She's much steadier than I am. Who am I to tell her not to trip? Yeah, evolution would take something like that. In fact, it takes far more than that. Let's dig into that. I fly in airplanes a lot. The other day I was flying in a plane. I looked out the window. There wasn't a thing down there but air. And the pilot said we were about 20,000 feet above the earth going, I think it was 400 or 500 miles an hour. I started looking around. I looked at the carpet on the floor of the plane, and I thought, that is not a flying carpet. This carpet doesn't fly. I looked at the doors going into the pilot area. The doors don't fly. The seats don't fly. In fact, the pilots themselves do not fly in and of themselves. So I got to thinking, I'm sitting in the middle of a bunch of non-flying parts. I became very concerned, so I got in touch with Boeing and said, how many parts are there to a Boeing 747 of the model I was in? And they came back 6 million non-flying parts, most of which are fasteners. And if you were to take these parts, we kind of illustrate that here, and just kind of lay them out in the runway. You know, I don't know what this part is right here, but I know one thing, that part does not fly. Wheels are good when you land, you need them, but wheels do not fly. We call an array of parts like this on the runway, 6 million parts, we call that complex. Complexity. What does the word complex mean? It means there's a lot of ways you could put this thing together, of which probably only one's going to work, right? That's all complexity means. So could I just get a promise out of you? If you get a discussion with an evolutionist, never again use a comment like this. How can you believe the eye could have formed by chance? It's too complex. That's not the issue. That just simply says, boy, there's a lot of ways you can put the eye together. There's a lot of parts to the eye. That's all you're saying with complex. The words you're looking for are integrated complexity. That's a deal changer. That means that the complexity is integrated in some way to work together. You want to get a good illustration of this? Show up early for the symphony next time and listen to the musicians tune up. Every time I hear this, I think, we're not getting any music out of this group. But when the conductor comes out, tip, tip, tip on the podium, everybody opens to a certain place in the score, and the conductor comes down, we segue from complexity to integrated complexity. Beethoven's Fifth Symphony or something like that. You see the difference between integrated, another word for it is specified complexity. Complexity is not the issue. It's the integration of the parts that take it out of the realm of chance. You know, there's a lot of ways you can shuffle a deck of playing cards, and the total number of combinations is absolutely astronomical. How many cards in a deck? Significant cards? 52? That means 52 factorial. That's how many different ways the cards could be arranged in a deck of playing cards. It comes out, you'd get any particular combination, and I mean any particular combination of 52, approximately once in this many tries. I don't know, I tried to name that number. I think it goes something like this: 81 million, trillion, 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 trillion. Boy, there's a lot of ways to get that combination wrong if you're looking for a particular combination. Now, is there any particular combination more likely than any other? No. Every one has one chance out of this many. Now, you go down and you buy a new pack of playing cards, and I recommend it because they're made in Erlanger, Kentucky now, U.S. playing card. You get a new pack of cards, you take it out. Let's say you never had a new pack before. You've been playing with that old pack that sticks together like a block. And you start looking at them. The ace of spades is in the top. And then it's a 2, 3, 4, 5, 6 on up through king of spades. Then it changes colors to hearts, and it goes ace through king on hearts. Then it changes color again, only now it goes from king down, king to ace. Changes colors again for the fourth suit, king to ace. So ace to king, king to ace, king to ace. Tell me, how many people think they throw them in the deck willy-nilly at the card factory? Nobody. But is that combination any more or less likely than any other particular combination of 52 cards? No. So what makes you think that's something special? Integration. 1 through king, king through 1, alternating colors. It's the specification or the integration of the deck that lets you know something's going on here. It's not just complexity. Boy, if I can solve that problem among you today when you talk to people, that would help. So anyway, what about chance and design? I looked it up in the dictionary. I always want to make sure I'm using the words right. Chance means the absence of any known reason why an event should turn out one way rather than another. Synonyms are fortune, fate, and luck. What about design? Design means to plan and fashion artistically or skillfully, to intend for a definite purpose, to form or conceive in the mind, to contrive, to plan. What do you see coming up again and again on design? Forethought. Knowing what it is you wish to do and then doing it. And that is specifically forbidden in our public schools today. You cannot teach that the eye is intelligently designed. You can say the eye evolved by mindless, purposeless, goalless chance, and it happened to lead to more offspring, therefore was selected for, and it left more offspring because just quite by chance it happened to be able to see, and that conferred some benefits. Man alive, if I'd have to use all of that for every organ I mentioned in a lecture, I'd never get through a lecture. So I just go ahead and tell you, hey, the eye is there so you can see. Sue me, I don't care. The eye is there so you can see. Guess what the ear's there for? Hearing. Boy, that's heavy thought nowadays. That's heavy-duty thought in a school. Well, have you heard of this guy, Richard Dawkins? He was at Oxford. He's retired now, and he's the one that wrote the book that says children should be raised to be atheists because anyone that raises them to be Christians is engaging in child abuse. And you know what we do with people who engage in child abuse? We take their children away from them. I believe we could go there if we're not careful. Well, anyway, it's this guy, Richard Dawkins, about whom it's been said he knows more things that aren't true than perhaps anyone alive. And in his book, The Blind Maker, on page 1, that would be the first page, he said this. This is a book saying there's no slightest trace of intelligent design in the human body. Got that down? Here's what he says in the first page. Biology is a study of complicated things that give the appearance of having been designed for a purpose. Wow, I would have tried to avoid that if I were an evolutionist. I really think sometimes God just gets in and takes over people's minds and makes them write these things, these evolutionists. Well, I agree with him. I mean, I have to say that's one thing I agree with even Dawkins. Biology is certainly the study of complicated things that look like they're designed. I'll give you just one little example. This is a little piece of the placenta. Placenta is about this big around, yay thick in the middle. And if you look at a placenta after it's been delivered as afterbirth, there's like lumps on the surface that were up against the endometrium, the uterus. And those little lumps are like looking at the tops of trees in a forest. There's approximately 20 little trees, they're called cotyledons, in a placenta. Each one has one trunk, and then they branch, and the branches have branches, and the branches have branches, all the way out to the twigs. This is one of the twigs. And you know, trees have bark. Well, a placenta has a coating of a cell here that you see this little red line around here. Notice the nuclei are puddled together. I can tell you something amazing about this, something you probably don't know. It may be your obstetrician doesn't even know this. The whole surface of the placenta is one cell. It's called syncytial trophoblast. It has millions, perhaps trillions of nuclei, but it's all one cell. That means you're not getting across this barrier here unless you go right through the cell, there's no way to sneak through between cells because the whole surface is one cell. It formed from the fusion of many separate cells called cytotrophoblasts. Now, here's where you see God's handiwork. The red blood cells inside the twig, see these here, and there's a white blood cell here. These are the baby's blood cells. They're completely separated by this seamless one-cell border, which, by the way, if you could flatten this cell out, it would occupy the area of a living room area rug, about 8 by 11 feet. That's a big cell. Here, this red blood cell is mother's red blood cell. So baby here, mother here. That makes sense? Got the barrier in between? Now, the baby has to make its own blood. That's one thing the placenta can't do. The placenta serves the function of the lung, the kidney, the GI tract, the endocrine system. I mean, a baby can be born without lungs and survive till you take the placenta away. It's just one marvelous organ. But it doesn't make blood for the baby. Baby has to make its own blood. How long is it going to live without blood? No time at all. What does a baby need to make blood? It needs to make hemoglobin, just for one. Hemoglobin contains iron, and its only source of iron is from mother's blood. Boy, have I got some bad news for you. Iron does not go across the placental barrier. It's impermeable to iron. Anyone see a problem here? Life's over. One generation, that'll be the end of placental mammals. The next generation won't be born because they can't make blood. By an incredible stroke of dumb luck, one of the 100,000 different proteins in our body belongs to a class of about 200 different proteins, averaging about 400 amino acids apiece. And one of them is called transferrin. Probably never heard of it, but you wouldn't be here without it. Transferrin goes across this barrier, picks up the iron from the mother, and is able to carry it across the barrier and release it to the baby's blood, without which end of the life. I've got a question for you. How many million years are you going to have to get this right? Now, here's a challenge to evolutionists. Out of 100,000 proteins in the body, I just want one. Transferrin. I'm going to put that in my pocket right here. I got it. You don't get it. But I give the evolutionists everything else on Earth. Boy, that's generous. Everything in the universe, all living things, I give them that as a head start. Wow, how generous can you be? I'm only holding back transferrin. They're done. You don't have a million years to get transferrin. You need it now. You need it for the next generation. I give you several hundred more examples like that if you got the time. No, I can see you're not interested in more. Got a neighbor. One neighbor puts up this fence, one neighbor puts up this fence. Don't you wonder about this guy? They built a fence down here. Which of the two fences has the most order, top or bottom? Top. Which one is the most complex? Bottom. You see, if you wrote an instruction set for building the fence, you'd say start with a stack of short boards and a stack of long boards, put up a short board, put up a long board, continue in this fashion until you run out of boards. That's the whole instruction set. What's the instruction set for this thing? I mean, where do you begin? We have boards missing, we have boards together. I guess one of the first questions we're going to have to deal with is this complexity or is this what? Specified complexity. Guess what? It's specified complexity. Your neighbor is using International Morse code. Instead of dots and dashes, he has short boards and long boards. So it'd be like did it, dot it, did it, dot it, down the line. It spells the word information. Now, if instead of a word you were doing a whole sentence, paragraph, or book, you'd get involved with grammar and syntax and all of that on top of what language does your neighbor speak? English, French, German, Russian? Once you know what language, what is it you want to communicate with him? Or her, as the case may be. And you can do it with boards. Do you realize you could write the whole Encyclopedia Britannica with boards? Does this give you a new respect for boards you never had before? No, it has nothing to do with the boards. You could do it with big rocks and little rocks, right? You could do it with flashing lights, dots and dashes. I mean, arbitrary decision. In fact, the code itself was arbitrary. There are other codes you could have used besides International Morse code. And by the way, nobody has ever observed a coding system come into existence by chance. Not ever. Not ever. Coding systems come from a mind, always. So, do we have a code in our body? Yeah, we have the genetic code. You've heard of that, haven't you? It's in the DNA. It's the source of information in the cell. Basically, it's in the nucleus. It looks like a phone cord. There's actually two of them wound together here. They unwind over a particular area. A copy is made called messenger RNA. It does no good in the nucleus. It needs to be in the cytoplasm, and here it is in the nucleus. By an incredible stroke of dumb luck, there are pores that the little message passes out through to get to the cytoplasm. Out there are little machines called ribosomes that have up to about 100 different proteins that make them up. The messenger is threaded through like movie in a movie film. And in doing so, there are 4 different units along its length that can be in different combinations, and it's combinations of 3 of these so-called bases that code for the proteins. So you can code for each of the 20 different, for amino acids. You code for each of the 20 amino acids so you get them in the right order. By the way, when this messenger comes out, you're not done. It can be cut up into pieces and reassembled and get something completely different. There are introns and exons. There are pieces that are deleted and pieces that are retained. You realize 2 organisms could have the same DNA, produce the same messenger, and produce very, very different organisms based on what do you do with the messenger after you made it? What kind of changes? So when you hear that a mouse is 80% identical to a human, bear in mind we're only talking about 2% of the DNA. We're talking about the DNA that codes for proteins. We're just beginning to learn what the other 98% is doing. They used to call it junk DNA because they said if evolutionists don't know what it does, it obviously doesn't do anything. But now they don't call it junk DNA anymore. They believe it's all the control switching that controls all these genes, turns them on and starts them and stops them, determines how long they work. So anyway, the messenger goes through and makes the protein. Here's the way it would look. You know these little beads people wear? They have letters, the alphabet, different colors. If we had 20 different beads, we had the number A through T in different colors. These could represent 20 different amino acids. And how long would our string of beads be? Well, on average, it would be 400 to 500 amino acids long, so I typed out 500 dots here for you to show you what the string of beads would look like. And at every dot, any one of these 20 could be there. And it's the sequence that determines the function of the protein. So what about hemoglobin? You know we need it. You've discovered that now. We have to have hemoglobin. It binds oxygen in warm water, which otherwise we wouldn't have any oxygen in warm water. And hemoglobin contains 539 different amino acids. And if you let the amino acids be represented by the letters of the alphabet A through T, this is one combination. How many different combinations are there? This many. That's how many different ways you can put hemoglobin together, of which only 5 are known to function normally in humans. 5 out of this. How big a number is this? Well, if we look at the first 9 zeros, no clock has ever ticked that many times because clocks haven't been around that long and they don't tick that fast. Every time we add a 0, the number gets 10 times bigger. Let's add a bunch of them. That's 80 zeros. It's estimated that that's the maximum number of atoms in the known universe. And we haven't even come close to looking at the total number of ways to put hemoglobin together. And we've already reached a number that probably exceeds, according to calculations, the number of atoms in the known universe. Let's add just a few more and we'll cut it there, 150 zeros. We still haven't begun to tickle this number yet. Statisticians call this universal probability bound. They say if your chance of something happening is worse than this, the opposite's a certainty. You start going along with numbers like this and using this, you undermine the whole statistical foundation of modern science. Well, to give you an idea how big this number is, I've tried to think, how can I convey how big this number is? And the best I've come up with is this. This number is so big, it's actually greater than the current American national debt in dollars. Yeah, I knew that would resonate with you. Well, let's sum it up. Give the evolutionists a chance to say a few things. Paul Davies is an expert on the origin of life, publishing in the journal New Scientist in 1999. He said, how did stupid atoms spontaneously write their own software, and where did the peculiar form of information needed to get the first living cell up and running come from? Here is the definitive answer from one of the top experts in the origin of life. No one knows. Or he says, nobody knows. Man, how about posting this in the biology classrooms of America? and identify that it's from Paul Davies, the premier origin of life expert, Arizona State University. Well, I prefer the Word of God myself, just a simple Christian. This is a verse so simple I understand it. For nothing is impossible with God. There's another one simple enough for me. Hebrews chapter 3, verse 4. For every house is built by someone. I'm not going too fast, am I? Every house is built by someone. But he who built all things is God. Why do people have so much trouble with this? Why is it most of the scientists I worked through down through the years don't believe this? I think this sums it up right here. Proverbs 20:12. The hearing ear and the seeing eye, the Lord has made even both of them. Now you got to be careful before you buy into that one. Because look at this verse. He that planted the ear, shall he not hear? He that formed the eye, shall he not see? How well do you figure the creator of the ear can hear? Can hear your thoughts. How well do you figure the creator of the eye can see? He can see into your hearts. This is the same creator who once said, you shall be holy or you shall be perfect as I, the Lord thy God, am perfect. How you folks doing on the perfection scale? I'm coming up real short. In fact, I'll be honest with you. I am absolutely the worst sinner that I know personally. How can I face up to a God that can look into my heart? I may be able to fool you people for a little while. I'm not fooling God. No wonder people run away from this. I'd do the same thing if I were in their shoes. You couldn't drag me into this museum. You know, on the last day, the Lord's going to come looking for me. I just know it. Just the way he came looking for Adam. Remember that after he sinned? Adam, where are you? Where were they, by the way? They were hiding behind trees from the creator of eyes and trees. This is not going to work. And then when God said, did you do the very thing I told you not to do? And Adam basically come back with, hey, don't blame me. It's his wife. You gave me. Whose fault was it? God's fault. It's no wonder in the 3rd chapter, verse 15, the next verse we read is, and then God repented of ever having created the heavens and the earth. He destroyed everything he created except for Adam and Eve, which he sent into eternal damnation. Okay, so that's not in the Bible. I made it up. But that's what it could have read. That's what it should have read. But instead, we get the most compelling example of amazing grace in the whole of Scripture. Right on the insult to God comes the condemnation of Satan and the promise of a Savior. Well, on the last day when the Lord comes looking for Dave Menton, I can hear it now. Dave Menton, where are you? I'm going to be hiding, just like Adam and Eve, not behind trees. I'm going to hide behind Jesus Christ. If he goes this way, I go this way. If he goes that way, I go this way, okay? So God looks, and he doesn't see me. He chooses not to see me. He sees Jesus. And he says, well, there you are, Dave. Why, you're perfect. You've never sinned in your whole life. And I think, oh, boy, that's not me. No, it's not me. It's Christ's righteousness imputed to me. And that's what Christianity is all about. It's a good place to end right there. Thank you for your attention. Appreciate it.